All right, hi. We're going to review solving systems by elimination today. This one is my favorite. I don't know why. I've always loved it ever since I was in school. And so I hope that you love it too. And here we go. All right, to solve by elimination, basically you're just going to eliminate either the x variable or the y variable within the very beginning. And then after that, you're going to solve for the other stuff and you'll see. So here are my steps, again, written out kind of weird because that's my train of thought, but hopefully watching examples will help you. So 1, you want to make sure that equations are in standard form, which looks like this: something times x plus something times y equals c. And you can see both of these are already in that form, so that's fabulous. Okay, you're going to stack them up, which is what we did here. They're already stacked up. And then you're going to say, which variable could I eliminate? Okay, so if you think about stacking them and adding these equations together, which variable would be easiest to make it go away by adding them? And in this one, we're actually in good shape because our y has a -3 and a +3. So we know we can get rid of y. Sometimes you have to do some fancy footwork, which we'll show you in the other examples. All right, so next step 4, we're going to add these equations together. So just add them. 2x minus 5x is -3x. Our y's canceled out because we had -3y plus 3y. And then we're going to add the last part, 39. Okay, now we have a very simple equation in terms of x, so we can get x alone by dividing both sides by -3. So x equals -3. Oh, awesome. Now we have x alone. We need to now figure out what y is. And so in order to do that, you're going to choose one of the original equations and you're going to write it. 2x minus 3y equals 9. Again, it doesn't matter which one you choose. Know that x is 13. So everywhere we see an x, we can put 13. 2 times -13 minus 3y equals 9. All right, we're going to solve this. 2 times -13 is -26 minus 3y equals 9. Now we want to get the y alone, so we're going to add 26. -3y equals 35. Okay. And divide by -3 to get y alone. And 35 divided by -3 isn't beautiful. So let's see. 35 divided by -3. That's the simplest form, it says. All right, so y equals 35 divided by -3. Hopefully I didn't mess something up here. -3x, 39. See, I can guess myself the same way you guys would. Let's check up here. Just make sure. 39 divided by -3. Yeah, it's okay. All right. So let's check our answer. So the answer would be -13 is our x and 35 over -3 is our y. So we're going to check the answer by going into Desmos and typing our two original equations. And we're looking for their intersection. So I can't see it. I'm going to zoom out a little bit and move my screen around. Here it is. And yeah, it was right. This is the same answer. You can see 35 divided by -3 is -11.667. And if you check your answer, there it is. So interesting, but yeah, I wonder if I copied the problem wrong. No big deal though, because math isn't always perfect, beautiful answers. All right, let's look at these two examples. Step 1, make sure they're in standard form, and they are. Stack them up, they're already stacked. And see which variable we can eliminate. So if we added these together, could we eliminate the x's, the y's? We can't. So this is where you have to do some fancy stuff. You're going to look and say, well, I don't know, what should I get rid of? And for me, what I see is that 2x and x might be easy to change. So I'm actually going to multiply this entire first equation by -2. Why do you think I chose -2? Well, you can see if I distribute, -2x plus 2x is going to end up equaling 0. So that's why I chose that. I don't need to mess with the bottom. So the top equation is now 2x minus 6y equals -12. And the bottom equation did not change at all. Okay, so now we're going to add our equations together. -2x plus 2x is 0. That cancels. -6y minus 7y is -13y. -12 plus -1 is -13. And let's get y alone by dividing by -13. All right, so y equals 1. That's nice. Let's see if we can figure out what x equals. So we're going to go back to one of our original equations. I'm going to choose the first one, but it doesn't matter which one you choose. We know that y equals 1. So everywhere we see a y, we're going to put a 1. All right, solve this equation. 3 times 1 is 3. Keep solving. We want to make the x alone. And we got x equals 3. So the answer to this would be written as a coordinate, x, which is 3, comma y, which is 1. And let's verify that we did it correctly by graphing it in Desmos. We're going to put our original equations. And can't see it, so we're going to zoom in. Sometimes I like to press home. Touch the intersection point, which is 3, 1. We have 3, 1. So we did it right. Awesome. Last one. Okay, same process. Are they in standard form? Yes. If we add, are they stacked up? Yes. If we just add them right now, we cancel out x or y. And the answer to that is no, we can't cancel out x or y right now. And so we need to figure out how to manipulate these equations in order to be able to do that. I like this 10, so I'm going to try to get rid of the y's. And again, this is a weird thing. So if you don't understand it the first time that you watch me do this, pause, rewind, watch it again, try some. It's kind of complicated. I'm looking at this because I think, okay, I'm just going to say if I can get them both to equal 90, I can cancel out the y's. One needs to be positive 90, one needs to be negative 90. So I'm going to multiply this whole first equation by 10 because that's going to change it to 90. If I multiply the whole first equation by 10, I'm going to need to multiply the whole second one by 9 to get 90 in this spot. But I want it to be negative, so I'm going to make it -9. All right, so let's go ahead and distribute. This is going to be 10 times 5x is 50x plus 90y equals -100. Okay, just distributed. Same for the next one. -9 times 7x is -63x. -9 times 10 is -90y. And -9 times -1 is +9. All right, so now you see we have that awesome spot right here where we have +90 and -90, and that's going to help us out. Okay, we're going to solve this equation now, or not solve, we're going to add them together. 50 plus -63 is -13x. The y's are gone. -100 plus 9 is -91. All right, we have x, So we're going to get x alone by dividing by negative 13 on both sides. And I feel like this might be 8, but I'm going to check it just to be sure. 91 divided by 13. Oops, 7. I was wrong. So x equals positive 7 because these are both negative. So now we know x. Okay, next step. Write one of the original equations. It does not matter which one, so I often just choose the top. And substitute everywhere we see an x, we can put a 7. Okay, 5 times 7 is 35. Okay, we want to get the y alone, so we're going to move the 35 by subtracting it from both sides. 9y equals negative 45. Divide both sides by 9 to get the y alone. Y equals negative 5. So the answer would be x is 7, y is negative 5. And one more time, let's verify that by checking it in Desmos. Remember to check in Desmos. You substitute your original equations, or you just write them down. You don't substitute them. 7x plus 10y equals negative 1. All right. And here's our intersection point, 7, negative 5. 7, negative 5 is what we got. So we got it right. All right. I hope that helped. Bye.